everybody. So thank you for the intro. We're going to be talking, yes, about CDP, as Justin kind of hinted at, but to get there, we're actually going to be taking kind of a little journey through the whole history of all of the kind of data access products that we have built and maintained over time to kind of frame how and why the heck we got here. So I'm Molly. I'm an engineering manager here on our platform team, previously known as the Horizon team, but we rebranded a while ago because we do a lot more than that, general data access. So let's start in the past. Hopefully this looks familiar. So for most of the history of the network, you basically had two options, right, to get data out of the network: Horizon and Hubble. Horizon, hopefully everybody's familiar with, likely so. It's a real-time API, two-way communication, so you can read and write from the blockchain, much more widely used. Hubble, on the other hand, is one-way communication, right? So it's read-only, more of like OLAP system, so for analytics use cases for the most part. Not as widely adopted as Horizon, but it actually has a lot more data. So if you're into that, you should actually check it out. We'd love to get more eyes on that. Now, if you didn't use one of these two things, chances are, maybe you ran your own watcher node, but chances are you didn't do anything, right? Because it's actually quite hard to get data out of the blockchain without one of these two tools. So let's dive a little deeper into Horizon, because that's kind of been the OG. Horizon, been around forever, right? I think it's 10 years old at this point, so pretty much as old as the network itself. And at some point, way back in time, way before my day, the foundation made the choice to host a version of this. That was with good intent. We wanted to allow everybody to get up and running super, super quickly, and it certainly did that. This is why you probably all are very familiar with it, right? Horizon, hopefully you're familiar with this as well, right? Answers a bunch of kind of questions for you. This first set we think of as kind of like current state questions, right? So what's the latest ledger? What's my balance? Did my transaction succeed? Things you kind of want immediate responses to, things that are available in the latest ledger or very, very recent history. These are very, very cheap questions to answer. Probably what you'd get out of most kind of like RPC, EVM, kind of RPC nodes. And generally, we find this is actually most of the questions that people ask, right? It's like 80 to 90% actually of the requests that people want. But Horizon does a lot more. It hosts historical data, right? So questions like, what's my account's full transaction history? That's a little bit more expensive to answer, right? But it tends to be less widely asked, or less often asked, right? You probably only need to ask that very occasionally when you're scrolling through your transactions. It also answers questions about derived data. So this one's a little weird. Think of things, if you're familiar with Horizon, like trade aggregations or fee stats, things like that. These tend to be a little bit more expensive. They are very opinionated APIs, and they really are specific to like some very targeted use cases, right? Trading API doesn't make a ton of sense in a generalized kind of RPC node, right? So anyway, this is super awesome. Horizon's great. It does a lot of stuff for you. What's the problem? Is there a problem? Turns out there is. Because that's a ton of data. That's so much data, in fact, that it's currently 40 terabytes, growing at a rate of a terabyte a month if you host full history. And now we heard from kind of Tomer yesterday, the product keynote, from Nico and from Sid this morning. This rate of growth, right, might actually get exponential, right? It's potentially not going to be linear. So 1 terabyte a month could be 10 terabytes a month. Could be more than that. That's very quickly becoming something completely unsustainable to run, right? It's quite a lot to operate, full history. We at SDF did it for quite a while. So I'm not going to lie to you and say It's easy. Some of you probably know that. Maybe you tried to run it yourself and failed, or found it was too hard, found it was too expensive. And if that's the case, you are definitely not alone, because a lot of people did that in the ecosystem. And we know that because everybody just uses our Horizon, SDF's instance of Horizon. Hopefully this is kind of obvious by my lovely drawing here, but we have effectively centralized a lot of our ecosystem around not only Horizon as a product, but our deployed instance, SDF's deployed instance of Horizon, right? We care a lot about decentralization. We talked about it a bit yesterday at the validator level. This is logical centralization around our deployed instance. It's just as problematic. Now we know that this happens because earlier this year and a couple times in the past, if our Horizon goes down, it has downtime that's actually unrelated to the network itself. The network is still closing ledgers. Network activity drops, not just a little bit, but or noticeably, but drastically. So that's kind of crazy, right? It means that a huge portion of the ecosystem is actually dependent on SDF's uptime. A little scary. If you're one of those people that is dependent on this, you should hopefully be a little worried now. I'm trying to scare you a little bit. You should be scared. And I want you to seriously ask yourself, right, if you, I may get in trouble for saying some of this stuff, but would you really want, if you were objectively looking at a vendor to put in your supply chain, would you really want one that is a huge denial of service vector? Maybe because I've said it here and now you know you can take down the network. But it's a free public good, right? Has no SLA at all, no uptime guarantees, technically. We do a good job, we try to do a good job, but there's no guarantee at all. Reserves the right to really aggressively rate limit you or completely block you if we feel like it. We could do that. And potentially the scariest, right? We are a nonprofit that is not SOC audited, and you have no visibility into our internal IT or security practices. Sorry, Alex. That's kind of scary, right? If you were going to put that through any kind of objective vendor analysis process, your legal team or compliance team would probably like laugh you out of the room, right? You don't want to be doing this, right? So hopefully, hopefully you're scared off at least our instance, right? But we're trying to encourage some of that decentralization, at least away from our instance, and you've probably seen some of these updates throughout the past year. The first of which being, right, we truncated our instance. It retains a year of history. Conveniently, that's also a little easy for us. And we're also going to stop serving ledger metadata from its APIs. That's actually rolling out in Protocol 22. So if you didn't know that and you're hearing that for the first time, get on it, because that's coming later this month. And it's a good time to remember, right, because we got some of this feedback when we truncated it. SDF Horizon, even Horizon as a product, is not synonymous with the blockchain. The data is always there, it's always on chain. All this means is SDF is not serving it for free anymore. Horizon is just a database in front of the blockchain. We could shove anything in there. We pinky promise not to, right? But that pinky promise is kind of the best you're going to get. So what you should do, right, is you should actually run your own Horizon. You should own your own data. If you care about data provenance, if you care about reliability, right, you should run your own, because that's really the only way you can guarantee that what you're getting out of the API actually came from the blockchain. So if you previously relied on Horizon, and you've listened to all this and you're sufficiently scared, you may be asking now, like, what the heck do I do, right? You can run your own, for sure. But as we saw before, right, full history may at some point be unsustainable. You could continue to run or hit the public version, kind of assume the risk associated with that. You're like, I don't really care about history, it's good enough. For now, sure. You could pay a provider. We have a lot of good infra providers in the ecosystem. But really what you should probably do is actually think about what data you want. Sounds obvious. Sounds obvious, but it's not, apparently. Chances are you care about a very, very tiny subset of the data in Horizon, probably fractions of a percent, probably like hundredths of a percent, even depending on your application. You don't need to store 40 terabytes to just access, a couple gigabytes of data. Just don't do that. But how do you get that data? Well, luckily for you, we have thought about this problem for a little bit, and we've got a couple options for you. So the first one being stellar RPC. This has been mentioned a few times. I must caveat that it's technically right now still called Sorbonne RPC, but it is also getting a rebrand with Protocol 22. That is because we see it as the canonical RPC for stellar, not just Sorbonne, right? So its APIs will mimic or intend to mimic those of kind of what you'd expect of a EVM RPC node. And it's intended to be extremely lightweight, much lighter weight than Horizon. And how you should use this is basically as a gateway to the network, right? So this is kind of an example application. Send transactions, query them back to your backend, filter out any data that you don't need, store that data to your own database. Doesn't sound that groundbreaking, right? Sounds kind of obvious. You may be asking yourself at this point, why I'm even giving this talk. Because yeah, it's quite obvious, or it should be quite obvious. We also have another option that is a little bit newer, called the Composable Data Platform. You've also heard this mentioned a couple times already yesterday and today. A bit of a mouthful, but I'm going to try to demystify it a bit here through kind of just walking through a very simple flow. So all it is, right, is we have this new service. We have this new service called Galexie. Galexie reads data from the network from Stellar Core. So it wraps Stellar Core in the same way Horizon, RPC, Hubble all do. And literally all it does is write that data to GCS. That's literally it. It's the dumbest thing ever. It's pretty simple. And that data is stored there in kind of a raw, unparsed format. Now, this is GCS. It could actually be anything, but we're keeping it at any data store, but we're keeping it simple for now. Then on the other end, we have a series of libraries that just pull data out of that raw data store. This ingest SDK has actually been around for a while, but not in a way that was super easy for people to use. It kind of abstracts away what your source of TX meta is, right? So if you're using the ingest SDK with just configuration changes, you can get data from captive core, or you can get data from GCS, or whatever data store is configured. So the intent is basically that, and then you store your data in whatever your application database is. So the intent here, right, is that each of these interfaces are pluggable. Really all we've done is take a bunch of stuff that was previously meshed inside Horizon and Hubble in this like monolithic app that you didn't really have access to, and pulled it out into separate components. So you can now pick and choose which ones you want. You can configure them differently. You can decide to write your own transforms because you hate our data model. You can do whatever you want. But the idea is that you wrap your own application, these libraries, in your own application. It's really simple. It's really, really simple. It's a bit abstract, though, right? A bit abstract at this point, right? So I just want to kind of get a little bit more concrete to drive the point home. So what could these applications be? The answer is really anything. So I have a bunch of examples here. The point here I want to show, right, is that you now have the freedom basically to choose the right data store option for your application. You did not have that with Horizon, right? Horizon uses Postgres. And there are some really obvious things that could be done better. Trade aggregations, I mentioned earlier. You could build a trading API that actually uses a time series database, like InfluxDB. As opposed to, in Horizon, that is actually kind of a crazy, convoluted set of multiple joins across a bunch of relational tables. It's horrible, it's terrible, it times out a lot of the time. If you're familiar with it, you know how painful it is to use. This is not a use case that's built for Postgres. Similar, gas tracker. You want to build a gas tracker, use a low latency key value store that has TTL built in, right? There is no reason, again, to use a Horizon API that does a crazy set of convoluted joins across relational databases. Now, that sounds actually like I'm hating on Horizon a little bit. I am a little bit, but Horizon does what it does for a reason, right? It's as we talked about earlier, it's a generalized backend kind of for the whole ecosystem. It has to do all these different use cases, right? And it has to do them all reasonably well enough, right? And Postgres is okay at that, right? It does most things good-ish, medium good. But if you have a very targeted use case, a very targeted application, you can very drastically optimize not only your data storage choice, but right, the size of that data, how much you need to store. Horizon also, keep in mind, is open source. It needs to be operator friendly. So you may say like, well, we could just dual write into all these data stores and Horizon could, serve them all. Well, operators probably aren't going to like that, right? If you're like, oh, install these 4 different data store choices and make sure you can manage all those with this Horizon. It's not going to fly. So Horizon has a different set of concerns, is basically what I'm trying to say. So no hate to whoever built that originally and my team that maintains it. But some key things I also want you to get from here, right? First is that this raw data, we've kind of made a distinction here between like our raw data source in like Medallion or ETL speak. Think of that like as our bronze data layer, and our gold data layer, right, which is our application data. Why does that matter? Well, that raw data is always there. You always have it to go back to. Whereas in the past, if you wanted to get some historical data, you'd have to spin up captive core, re-ingest, right, from Genesis, maybe. Think of kind of a use case for a wallet backend. You're storing a very little amount of data in Mongo. Your life's great. But you're filtering into your database only data that's relevant to accounts that your wallet that you know about, right? Because why store anything else? So you have a very small data footprint. But now your product team comes to you, they want to add a feature that's like, you know what? If there's an existing account on the network, we want somebody to be able to import that and have it show their transaction history, right? Okay, well, you've now got an account that you weren't saving data about before, and you need to somehow get their transaction history. Really not possible using captive core, but here you have that raw data, right? Account onboards. Why don't you just drop an async job to go backfill the history for that account? It goes back to the raw data source, parses it out. Maybe you have a little spinner for a little bit, but it's there, right? So you kind of always have that to go back to if you need it. Another big win in this architecture, which is also very subtle, there's a lot of subtlety here, is moving captive core out of the lifecycle of your application. So captive core is run by Galexie. So none of your actual applications ever have to run captive core. You might be thinking, what does that mean, right? Probably don't realize what a big deal this is because historically Horizon has done this for you. So I love that for you. You've never had to feel that pain, but we hope to never make you feel that pain. No shade to core. I should have hit that earlier. Mind blown. But to show you, basically, to kind of prove what benefit we really get out of moving captive core out of the lifecycle of the application, I'd like to share some stats on what we saw when we basically refactored our legacy products to use this architecture. So for some context, in a former life before CDP, it took you 10 weeks to spin up a new full history horizon. Actually, Vibrant did this recently. I think it took them a little longer, like a little over 3 months, maybe more. That's pretty crazy, right? That's like if you applied for SCF and you want to apply to the next round, but you're not even getting started by the time the next round runs around because you don't have any of your data yet. That's really not great. With Galexie, we're able to export the full history of the blockchain in 4.5 days, which is a pretty drastic increase. You may be asking, well, that sounds hard. No, it was not. It was not expensive either. Cost us about $1,000. This is actually rounded up to the nearest 1,000. It cost us like $650 something. It's pretty cheap to get the full history of the blockchain. And if you recall, Horizon database full history, 40 terabytes. Galexie, or this GCS lake, is 3 terabytes. That is crazy small. It's actually smaller than the history archives, and it has significantly more data. This is all the data, ledger metadata, that comes out of a Watcher node. History archives does not have this level of detail, and it's smaller because it's compressed, right? History archives is not. And that costs us about $100 a month to host. If you're at Tomer's talk, you heard this yesterday, but our Horizon instance costs us about $95,000 a month to host. We are probably a special case, right, because ours is obviously far more drastically used than any that you may run yourself, but that's pretty different. That's a lot better. Our products, Horizon and Hubble, right, can use this setup because, as I said, they wrap the ingest SDK. They can point to captive core, or they can point to GCS. So we did this for Horizon, and we're able to spin up a full history of Horizon in 1 week. So we got over 10 weeks down to 1 week. You can run this in parallel with your export. So basically a 10x improvement, which is crazy. And, oops. Similarly, for Hubble, 4 days to spin up a new instance of Hubble. Not a lot of people do this, probably because it's burdensome, and now it is not. Hubble actually was able to get captive core fully out of the lifecycle of its application. They never have to use it ever again. And that's brought their kind of job execution time down by 5x. This saved us a ton of money. This has lowered the latency of all of our data in BigQuery, or the gap, right, recency between when the last ledger closed and what you can see in BigQuery. It's pretty crazy. And actually, I didn't have this on here, but we had some data engineers join recently, and because captive core is removed completely now from the lifecycle of Hubble, we realized recently, we had an onsite last week, that they didn't even know what captive core was, and they didn't know the pain that we previously had to go through to make it work. And I love that for them, and I hope that that's the case for you guys. I'm a little jealous as well, but that's big, right? Because now they can actually focus on what they do and not operating some system that they really have no background or a competency to do really fast. So what I want you to take away from this is it's super fast, right? Well, a week is still, it's not nothing, but compared to where we were, it's super fast, it's incredibly cheap, and it's incredibly easy to use. And that I may not have proved to you in this time, but if you come tomorrow to the partner stage, I'm going to be walking through an example of, this is actually a real GitHub issue that was filed a few weeks ago by Alien 2108. I don't know if you're here. I don't know who you are, but let me know. And we're going to be walking through why this is actually very difficult to add to Horizon, but would be extremely easy to add to your own custom ingestion engine. So we're going to attempt some live coding and do it in that hour if the demo gods allow. But also have a ton of other places here you can go to learn more. Want to pitch our Discord developer meeting. It's every Thursday. And next week, my team is actually at home doing a hackathon this week. And we're going to have a bunch of really cool examples at next week's developer meeting. Not tomorrow, the next Thursday, of what kind of applications you could build using CDP. There's some crazy stuff. It ranges from the useful, like a trade aggregation API. We have a full history RPC that goes to cold storage for that data beyond the retention window. We have somebody building a hardware microcontroller, lock a safe when a contract is invoked. We've got some weird stuff too, but that's the point. It's all very easy. So come on down to that. But that's all I got for you. And I will take questions if anybody has any.